4.4 compound angle formula proofs. So by the end of today's lesson, you should be able to use a compound angle formula to find the exact value of a trig expression involving the addition or subtraction of two angles. So a trig expression that depends on two or more angles is known as a compound angle expression. Now, I'm not going to prove any of these formulas. These are all on your formula sheet. However, I will just quickly go through them. So this is the cos of A minus B, which is equal to cos A cos B plus sine A sine B. A and B are angles as usual. You know, beside the cos here, those are angles. So A minus B is an angle, A is an angle, B is an angle. You do not distribute cos A minus cos B to get the result of this. You have to use an identity. This is an identity. Cos A minus B is equal to all of this. Okay? So do not be tempted to just distribute cos through there. That's not what you do. All right, so cos A minus B. There's that first one. I'm not going to show you the proof, but it's there if you want to go through it or come and see me at lunch. The addition formula, cos A plus B, is cos A cos B minus sine A sine B. Sine addition. So the sine of A plus B is the sine of A cos B plus cos A sine B. And the last one is the sine of A minus B is equal to sine A cos B minus cos A sine B. So these are all on your formula sheet. So let's just see some examples of what we do with this. Okay, so the first one says, show that the formula cos x minus y is equal to cos x cos y plus sine x sine y, and show that that's true for the two angles pi by 6 and y equals pi by 3. So I'm going to write cos pi by 6 minus pi by 3, and that's going to equal, everywhere there's an x, I'm putting pi by 6, sine pi by 6, sorry, sine pi by 3. Okay. Well, when I subtract these two, I get the cos of negative pi by 6, I believe. Common denominator pi by 6, 1 minus 2. Yeah. And then I can actually start evaluating all of these because these are all special angles that we can get the exact value for, right? So pi by 6, we will write that out. That's 1 root 2, 3. Pi by 3, of course, is root 3 over 2. So the cos of pi by 6 is root 3 over 2. The cos of pi by 3, if I'm up here, that's going to be a half. The sine of pi by 6 is a half. And the sine of pi by 3 is root 3 over 2. The cos of negative pi by 6. So if you've got a negative angle, this one I have to draw on the Cartesian plane. Remember, I'm going clockwise for negative angles, and I'm only going pi by 6. This is pi by 6, negative pi by 6. This reference angle is positive pi by 6, however. So I know across from pi by 6 is the 1, the root 3, and the 2, and actually we'll put a negative 1 there because we're below the x-axis. And so the cos of negative pi by 6 is root 3 over 2. It's positive in that quadrant, right? It's not the cos of the square root of 3 over 2, which I've seen the students do. This is equal to the ratio. Okay. And then I'm going to just expand just by multiplying tops by tops and bottoms by bottoms. So that's true. And then the last thing we're going to say is root 3 over 2. And when I add those together, I get 2 root 3 over 4, which simplifies down. I'm just going to squeeze this in here. Square root of 3 over 2 equals the square root of 3 over 2 when I simplify that. Left side equals right side. Okay, so we've shown that it's true for x equals pi by 6 and y equals pi by 3. Okay, next question. It says use an appropriate compound angle formula to express as a single trig function, and then use and then determine an exact value for each. So I can see this has the form sine of an angle, cos of an angle, minus cos of an angle, sine of an angle. So I know that that one is sine of x minus y. And I know that the sine of x minus y is sine x cos y minus cos x sine y, right? So I've looked at the form of this to figure out which of the 4 compound angle formulas is appropriate to change this into, because as it is, I cannot evaluate some parts of this. I can figure out what the sine of pi by 4 is, that's no problem, but I don't know what the exact value of the cos of pi by 12 is, so I have to morph this into something else. So now I know then that my x is pi by 4, my y is pi by 12, and that's, might as well write it all out, sine of pi by 4 cos pi by 12 minus cos pi by 4 sine pi by 12. Okay, so I know that this is going to be the sine. When I combine these, this is 12, this is 3 pi minus pi. I don't want to write this out again. I really should have just done this, equals, 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 and just ignored all this. That would have made it much nicer and simpler. And this is going to be the sine then of 2 pi by 12. And the sine of 2 pi by 12 is the same as the sine of pi by 6. And the sine of pi by 6, if I draw my triangle, pi by 6, 1 root 3, 2, so the sine of that, it's a half. Okay, so the exact value of that whole thing is a half. Okay, I won't bother writing out the ratio, not the ratio, sorry, the identity, but this is cos plus sine, so I know this one is going to be cos, and it's going to be the cos of the first angle, 10 pi by 9, minus 5 pi by 18. And then I know that this combines when we subtract. This is a 10, so this is 20 pi minus 5 pi, which is the cos of 15 pi by 18, which is the cos, when I take out the 3 from the top and the bottom, cos of 5 pi by 6. 5 pi by 6 I should draw in the Cartesian plane. I know that it's almost 6 pi by 6, so I'm going to terminate here in quadrant 2. That's theta equals 5 pi by 6. I know that it's going to form a right triangle with my reference angle being 1 more pi by 6 to get me to 6 pi by 6. Across from that's the 1. Underneath here is the negative root 3 and then the 2. And so the cos of 5 pi by 6, stick your finger on the angle, negative root 3 over 2. Makes sense that cos is negative in that quadrant, right? All right. Use an appropriate... Did I forget one? Is that the only... Yeah, we're okay. Okay, use an appropriate compound formula to determine an exact value for the sine of pi by 12. All right, so this one's different. I can't figure out what the sine of pi by 12 is exactly because I don't have a triangle that I can use to figure out the sine of pi by 12. So I need to change this into the sum or difference of 2 angles that I do know the ratios for. So my best advice with this one is just to pick it's not random, of course. You're going to pick one of the ratios that you do the angles that you do know the ratio for. So for instance, I could pick pi by 4. Now, I know that pi by 4 is greater than pi by 12. So I'm going to say pi by 4 minus some angle is going to equal pi by 12. And the goal here is if I can get my x, my unknown, to be another of the angles that we do have the ratios for, then I will be able to rewrite it as a difference, pi by 12 as a difference, right? So let's rearrange this. X equals pi by 4 minus pi by 12. Common denominator 12. This is 3 pi minus pi. This is 2 pi by 12 equals x, and then x is pi by 6. Hey, that's one that we like. So I'm just going to go back up here. I'm going to just use this whole space here. I'm going to go back up to the beginning then, and I'm going to say that pi by 4 minus pi by 6 equals pi by 12. Well, that's nice. So now I can rewrite sine of pi by 12, and instead of writing that, I can write it as the sine of pi by 4 minus pi by 6. Yay. All right, and I know how to evaluate that. I'm going to use my identity. So it's the sine of pi by 4 cos of pi by 6 minus the cos of pi by 4 times the sine of pi by 6. And again, I know, I'm going to show my proof though. I know pi by 6, triangle, pi by 3, root 3, 1, 2, and I know my other triangle, 45, 45, which is better known as pi by 4, 1, 1, root 2. All right, so the sine of pi by 4 is root 2 over 2. And you could have written 1 over root 2 and then rationalized later, but I know that it's root 2 over 2 when you rationalize it. Sine of pi by 6, sorry, the cos of pi by 6 is root 3 over 2. Minus the cos of pi by 4 is also root 2 over 2. And the sine of pi by 6 is 1/2. When I simplify this, just multiply underneath the radical there. So that's the square root of 6 over 4 minus the square root of 2 over 4. And I would probably like to just express that as one rational. So it's the square root of 6 minus the square root of 2 all over 4. That's the exact value for that one. Why don't you pause the video and try to do the next one using the first example as a template. And come on back and I'll do it for you. Okay, so the cos of 5 pi by 12, I'm going to pick again. Let's try picking pi by 4. Sometimes you'll pick wrong, and you'll end up with something that doesn't work. And if that's the case, then you're just going to pick another of the ones that you know and continue to try and find a pair that works. So 5 pi by 12 is definitely bigger than pi by 4, right? If I multiply the top and the bottom by 3, I get 3 pi by 12. So I know then, if this is smaller, pi by 4, that I'm going to have to add something to it to get 5 pi by 12. So I'm going to add x, and I want to get 5 pi by 12. So let's figure out what that x is. We'll just rearrange this. And we're going to find the common denominator. Oh, and again, it's 2 pi by 12, which is pi by 6. Okay, so that's nice. So pi by 4 plus pi by 6 is equal to pi by 12. Let's just write that down. So I'm basically just going back up to there, right? So I know then, was it sine or cos that I was finding? It was cos. So I know that the cos of pi by 4 plus pi by 6. Now, if you're following along here and you did not get that pair, you got a different pair, the only thing I can tell you is that that's okay. Just make sure that our final answers are the same, okay? Our solutions can look different, but the final ratio should be the same. Okay, so I'm going to apply the identity then. So I know it's cos of the first angle times the cos of the second angle, and then it's different sine, and it's the sine of the first angle times the sine of the second angle. Okay, so I'm just going to say equals, and the cos of pi by 4, we know that is root 2 over 2. We know the cos of pi by 6 is root 3 over 2. Minus the sine of pi by 4, again, root 2 over 2. And the sine of pi by 6 is a half. Okay, you should, for every solution, draw... Oh, I'm just going to pause for a second. Okay, so sorry, I was in the middle of drawing my triangle there. Oh, goodness. Okay, so this is going to be pi by, what do I need? I need pi by 6. So across from that is 1, 2, root 3. And I need the pi by 4 as well, so I've got to draw that one too. Okay, so I've drawn them, I've got this, I'm going to multiply this out, so this is root 6 over 4, just tops by tops, bottoms by bottoms, root 2 over 4, and you end up with the square root of 6 minus the square root of 2 all over 4. Okay. Is that the last of it, or is... Oh, there's another one. All right, so this is a different question. Angles x and y are located in the first quadrant such that the sine of x is 5 over 13 and the cos of y is 3 over 5. Determine an exact value for the sine of x minus y. Now, I find students get confused in this question because they think that this represents an angle. It does not. It's sine x. So sine x is a ratio, okay? So you cannot put these in here for x and y. So it's telling you that it wants you to find sine of x minus y, and it's telling you sine x, and it's telling you cos y. But if I'm trying to find the sine of x minus y, I know if I use my identity, I need to know the sine of x times the cos of y minus the cos of x sine of y. So I've got the sine of x, I've got this one, I've got this one, but I don't have the cos of x and the sine of y. So let's deal with x first, okay? I have the sine of x, so I'm going to draw. We know that x is an angle in the first quadrant, so I can just draw this in the first quadrant, angle x. There it is. I know that the hypotenuse then is 13, and if it's the sine of x, this is opposite. Okay, so opposite over hypotenuse, that's the sine of x, 5 over 13. I also know that this is going to be the 5, 12, 13 triangle. Now I know that, but you might not know that, but you do know Pythagorean theorem, obviously. So you would just use h squared equals a squared plus b squared. You know that the hypotenuse squared is equal to a squared plus 5 squared. 169 equals a squared plus 25. Subtract it off, take the square root, and you're going to end up with 169 minus 25 equals a squared. You're going to end up with plus or minus, when you take the square root, of 12. But because we knew, sorry, not the square root, a is the plus or minus 12. We knew that this was an angle in the first quadrant, so we know that that is a positive value, that A value. So we're only going to, because we know that A must be greater than 0, we've got that A equals 12. Okay, so now we're going to, now that we know that, we can figure out what the cos of x is. So let's just write, so cos x equals 12 over 13. That's going to come into play in a minute. Let's deal with angle y. So I know that angle y is also an angle in the first quadrant. I'll draw it. And I know that the cos of y is 3 over 5, so that's adjacent over hypotenuse. And I know that this is a 3, 4, 5 triangle, but again, you, if you don't know, would need to show, and you should probably show show it anyway, just in case. I might miss it if it's on a triangle or something, so be careful about that. So we've got h squared equals, 5 squared equals 3 squared plus b squared, so b squared equals 25 minus 9, b squared is 416, b is equal to plus or minus 4. And we are going to consider only the positive, so we're going to say b equals 4. All right, from that then, we can say that the sine of y is 4 over 5. And now we have all the pieces of information to fill into our puzzle up here, because now we do have the cos of x and the sine of y. So I can go ahead then, just do it over here. So the sine of x minus y, I don't know x and I don't know y, and I'm not being asked to find x and y, I'm being asked to find the exact trig ratio. So I'll put in sine x, that's 5 over 13. And I'm going to put in cos y, which is 3 over 5. And the cos of x is 12 over 13. I'm trying to go by memory here. And the sine of y was 4 over 5. That's going to equal 15 over 65 minus 48 over 65. This is going to be minus 33 over 65. So the sine of x minus y is minus 33 over 65. Now, that's a negative ratio. Does it make sense that this could be negative? Well, it could be negative if the angle x was smaller than angle y, because then you would end up taking the sine of something that was a negative angle, and it would be down here, and yes, that ratio in the fourth quadrant for sine is negative. So it does make sense that this answer could be negative. Okay, be careful in questions like this, because if x and y are not in the first quadrant, if they're in another quadrant, you're potentially going to get some of these ratios as negative. You would choose the negative values. For instance, if we knew that x was an angle in the second quadrant, if we were told that, then this would be negative 12 over 13 for cos. It would still be positive for sine x, but it would be negative for cos x, right? Okay, so that's it. Good luck with your homework. Thanks for listening.